Okay, so we're doing some introductory kinematics here. And here's the problem. The position of a particle moves along a straight line, and it's defined by this relation, x equals t cubed minus 6t squared minus 15t plus 40, where x is in feet and t is in seconds. And then we've got to determine these four sub-problems, A, B, C, and D. So let's start with A. The first step we need to do is write down the equation for the velocity. Let's see, here we go. Velocity is just the derivative of the position, and we've got it up here. So we just take the derivative of this, of x up there, and we get 3t squared minus 12t minus 15. And so for part A, the question was, when is the velocity equal to 0? So we just set the time at which the velocity is equal to 0 is when this is equal to 0 here. We solve this using algebra. This is a quadratic equation, and we can get the solution like this, minus 1 second, or t equals 5 seconds. Now this is, of course, let's see, describing the motion of a particle that starts at t equals 0 and goes on, and so really we're not concerned with the negative solution. We're only concerned with this. So t equals 5 seconds is when that occurs. Now I want to draw a little graph here of the velocity as a function of time. Let's do that over here. So here's going to be time. Here's the velocity. Now what we know is that it crosses v equals 0 at minus 1. So that would be kind of like around here. And at 5 seconds right here. And we know that at very large times, above 5 seconds, this you can tell it's going to be positive. So it ends up looking like this. It's negative for some time down here. And then heads up this way, the typical quadratic equation. And so the point is that at certain times between, let's see, what do we have here? This t equals 5 is right here, and this one is t equals minus 1, but the velocity is negative between those times. So let's write that down here. V is less than 0 for t less than 5. Starts at 0, so for this time it's negative, and then it goes positive. Now I'm going to scroll down some. So we scroll down, get some more space there, and we can work on part B. And that was the question of what is the position and the distance traveled when v equals 0. So we know that v equals 0 at t equals 5 seconds. That's right there. V equals 0 at when the time is equal to 5 seconds. And so the question is, what's the position and distance traveled? Well, let's do the position first. We just need to evaluate x at t equals 5 seconds. And we'll also look at x at t equals 0. And that'll be, this one will give us the distance traveled. Since we don't really care about the direction, we'll actually take the absolute values here. Anyway, so let's go back and plug this in to evaluate the x at t equals 5. Let me scroll back there, show you what x is. There's x up there. So I'm going to go in and evaluate that. So x at t equals 5. Let me write this here. So we'll go x equals at, let me do that again here, slip there, at t equals 5. And that's going to be equal to this. If I plug it in, it's 125 minus 150 minus 75 plus 40. And that comes out to be minus 60. So that's the position at t equals 5. At t equals 0, this is much easier to plug in, and it just comes out to be 40. So to answer part B, let's see, the position at t equals 5 is minus 60, and we're in feet. There's our position. And the distance traveled was the difference between those two, minus 60, minus 40, that's minus 100, or it's traveled 100 feet. That was the distance traveled. Okay, so now we're on part C. What's the acceleration of the particle at that time being t equals 5 seconds. So we just need to calculate for part C the acceleration at t equals 5 seconds. The acceleration evaluated at t equals 5 seconds. So let's write down the acceleration, and we know what that is. That's just the time derivative of the velocity. Let's take a look back. We have to scroll back here. What's our velocity? And here we have it. It's dx dt 3t squared minus 12t minus 15. So we're taking the derivative, the time derivative of this 3t squared minus 12t minus 15. So once we take that derivative, we get that the acceleration as a function of time is simply equal to 6t minus 12. And let's evaluate a at 5 seconds. We get 30 minus 12, that's 18. And our units here are in feet per second squared. And there we go, there's our answer. 18 feet per second squared is the acceleration at t equals 5 seconds. Now, let's see, we're on part D, the final part here. Let's go back up and look at that. They want to know what's the distance traveled. Distance traveled by the particle from t equals 4 to t equals 6 seconds. Now this is going to be a little tricky. Why? Because we want to know the distance traveled. And the distance, well, look at this. We've got a little typo here. There should be a t in there. Okay, so the distance traveled from t equals 4 to t equals 6 seconds. Now remember that the velocity was negative before 5 seconds and then positive after 5 seconds. So what's going on here? Let me scroll down and draw a little diagram here.